The service head must be weatherproof and raintight, meaning it must prevent water and moisture ingress, even during heavy rain or storms. The plastic insulator typically has 5 holes. 3 large holes accommodate the 3 wires, 2 smaller holes are for the screws, and 1 even smaller hole is designated for the grounding wire. When using a 2-inch electrical metallic tubing, or EMD, service head with 3 wires, position the wires within the 3 large holes. Securely tighten the screws to firmly hold the wires in place. Connect the grounding wire to its designated hole. If the plastic insulator breaks, replacement with a new one is essential. No other material is deemed suitable as a substitute. Once the new plastic insulator is installed, thoroughly seal the service head using a weatherproof sealant. This measure aids in excluding water and moisture, thereby ensuring the service head remains raintight. Electrical codes mandate specific requirements for service heads to guarantee safety and prevent water from entering the electrical system. Water intrusion can lead to corrosion, short circuits, and other hazardous conditions. It's crucial to understand these requirements to perform installations correctly. Service heads are typically made of metal or plastic. The choice depends on the application and local electrical codes. Metal service heads are generally more durable, while plastic ones are lighter and easier to work with. The size of the service head depends on the size of the service entrance conductors. The conductors must fit comfortably inside the service head without being damaged or stressed. When selecting a service head, ensure it is listed for wet locations. This listing indicates that the service head has been tested and approved for use in environments exposed to rain and moisture. The installation process is critical for maintaining a weatherproof seal. Firstly, ensure the EMT conduit is properly secured to the service head. Secondly, tighten all connections to prevent water from seeping in. Thirdly, apply weatherproof sealant to all joints and seams. The National Electrical Code, or NEC, provides detailed guidelines for installing service heads. Consult the NEC for specific requirements in your area. Improperly installed service heads can lead to electrical hazards and code violations. Common mistakes include using the wrong size service head, failing to tighten connections properly, and neglecting to apply a weatherproof sealant. Always use the correct tools for the job. Pliers, screwdrivers, and wire strippers are essential for installing a service head. Ensure all tools are in good condition and properly insulated. Before starting any electrical work, turn off the power at the main breaker. This safety precaution prevents electric shock. Double check that the power is off using a voltage tester before touching any wires. When working with electrical wires, wear appropriate personal protective equipment, or PPE, including safety glasses and gloves. These items protect you from electrical hazards and physical injuries. Consider hiring a qualified electrician for complex electrical installations. Electricians have the knowledge and experience to perform the work safely and correctly. If you are unsure about any aspect of the installation, consult with a qualified electrician. Electrical inspections are often required for new electrical installations. Contact your local building department to schedule an inspection. Electrical inspectors ensure that the work complies with the NEC and local codes. Maintaining a weatherproof service head is an ongoing process. Regularly inspect the service head for signs of damage or deterioration. Replace any damaged components immediately. Reapply weatherproof sealant as needed to maintain a tight seal. Over time, the sealant can dry out or crack, allowing water to enter. Check the condition of the EMT conduit as well. Corrosion or damage to the conduit can compromise the weatherproof seal. Consider using heat shrink tubing to further protect connections from moisture. Heat shrink tubing provides an extra layer of insulation and sealing. Choose heat shrink tubing that is specifically designed for outdoor use. Another method for sealing connections is using electrical tape. However, electrical tape alone is not sufficient for creating a weatherproof seal. It should be used in conjunction with weatherproof sealant. When applying weatherproof sealant, follow the manufacturer's instructions carefully. Apply a generous amount of sealant to all joints and seams. Allow the sealant to cure completely before exposing the service head to rain or moisture. Different types of weatherproof sealant are available. Choose a sealant that is compatible with the materials being joined. For example, use a sealant that is specifically designed for use with plastic or metal. Some sealants are paintable, allowing you to match the color of the service head to the surrounding area. This can improve the aesthetics of the installation. Consider using a drip loop in the service entrance conductors. A drip loop is a bend in the conductors that directs water away from the service head. This helps to prevent water from entering the service head. The NEC specifies the minimum size of the service entrance conductors. Ensure that you are using the correct size conductors for your application. Undersized conductors can overheat and cause a fire hazard. Properly sized conductors are essential for safe and reliable electrical service. The NEC also specifies the minimum clearance requirements for service entrance conductors. Ensure that the conductors are not too close to the ground, buildings, or other objects. Insufficient clearance can create a safety hazard. When installing a service head, consider the location of nearby trees. Tree branches can damage the service entrance conductors or the service head. Trim any branches that are too close to the electrical service. If you are replacing an existing service head, disconnect the power before removing the old service head. Carefully inspect the old service head for signs of damage or deterioration. This can help you identify potential problems with the installation. Take photographs of the existing installation before starting any work. These photographs can be helpful for reference during the installation process. When running the service entrance conductors through the EMT conduit, use a pulling lubricant to reduce friction. This makes it easier to pull the conductors through the conduit without damaging them. Avoid bending the service entrance conductors too sharply. Sharp bends can damage the conductors and reduce their ampacity. Use a conduit bender to create smooth, gradual bends. When connecting the service entrance conductors to the service panel, use the correct type of connectors. The connectors must be compatible with the conductors in the service panel. Tighten the connectors securely to ensure a good electrical connection. After completing the installation, test the electrical service to ensure that it is working properly. Use a multimeter to check the voltage and current at the service panel. If you encounter any problems, consult with a qualified electrician. Regularly inspect the grounding system to ensure that it is functioning properly. A properly functioning grounding system is essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to prevent electric shock. Check the grounding electrode connection to ensure that it is tight and corrosion-free. The grounding electrode is typically a metal rod that is driven into the ground. The NEC specifies the requirements for grounding electrodes. Ensure that you are using the correct type and size of grounding electrode for your application. Consider using a surge protector to protect your electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protectors divert excess voltage away from the equipment, protecting it from damage. Surge protectors are available in various types and sizes. Choose a surge protector that is appropriate for your application. Some surge protectors are designed to protect the entire electrical system, while others are designed to protect individual appliances. When installing a surge protector, follow the manufacturer's instructions carefully. Surge protectors typically need to be grounded to function properly. Periodically test the surge protector to ensure that it is working properly. Some surge protectors have a built-in indicator that shows whether the surge protector is still functioning. Replace the surge protector if it fails the test. Always prioritize safety when working with electricity. Electricity can be dangerous if not handled properly. Follow all safety precautions and consult with a qualified electrician if you have any questions or concerns. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Improper electrical work can lead to serious injury or death. By following these guidelines, you can ensure that your electrical service is safe, reliable, and compliant with the NEC and local codes. Remember that electrical codes and regulations can vary depending on your location. Always consult with your local building department to ensure that you are complying with all applicable requirements. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. Electricians have the knowledge and experience to perform the work safely and correctly. Keeping your electrical system in good condition is essential for the safety and comfort of your home. Regularly inspect your electrical system and address any problems promptly. This will help to prevent electrical hazards and ensure that your electrical system continues to function properly for many years to come. Ignoring electrical problems can lead to more serious and costly repairs down the road. Proactive maintenance is the best way to keep your electrical system in good condition.